Before I even start, I need to acknowledge, I think I saw that Amy Ackerberg Hastings is on the call, and I just wanted to acknowledge that she's done research in this area too, and I made heavy use of her research, and hopefully I have something to add to it. So let me just start there. But I am, as Rob said, I'm a math teacher and a curriculum coordinator at the Brearley School. I also teach math education at Teachers College. My research generally has been about American math education in the 19th century. It's fascinating as a time period because there were so many changes going on throughout the world, or at least throughout Europe and the places that Europe influenced. Changes in both math and in math education. And the United States lagged well behind France and Germany and other parts of Europe, but I actually believe that the United States is interesting as a case study actually because it lagged behind. Because by studying the United States, we can see how ideas are disseminated from one country to another, and sometimes what gets in the way from one country embracing new ideas fully. So I'm going to be focusing on the spread of French mathematics and ideas about mathematics teaching through one particular highly influential textbook. As you see here, this is Charles Davies' 1835 adaptation of Bourdon's 1817 algebra textbook. So before I dive in, I want to give you a roadmap of my talk to help orient you. First, I want to convince you that this particular book by Davies is historically important because of its influence on the United States. Second, I want to take a step back and give you a little background about the French origins of the book, how it was part of a larger story of how French ideas influenced the United States, and how that happened in particular through its influence on the United States Military Academy at West Point, which is where Charles Davies was a professor, a student, and then a professor. Third, I want to talk exactly about what ideas were transmitted to the United States, what ideas about mathematics and mathematics education were transmitted to the United States. And so there are really two parts to this idea. First of all, Bourdon's book itself represented a particular moment in time, a particular view of mathematics. And then Davies himself made choices about how to adapt that book for American audiences. All right, so this is part one, why we should care. Davies' adaptation of Bourdon was published in 1835, and this is an ad for Davies' books that appeared in a Vermont newspaper in 1839. There were many, many such ads, and this is just one. So I want to call your attention to the language. It's been the intention of this course to unite the analytical methods of the French with the practical methods of the English school. So this is how the books were marketed in the United States. I'm not sure that the people who purchased these books for schools really understood what that meant. In the United States, decisions about education were, and to some extent still are, very decentralized. And a lot of the people making these decisions about what textbooks to buy were not experts either in education or even in mathematics. So they would have relied on claims like these. But it's clear that the Frenchness of the books was a big part of the appeal. There was a sense that the French were ahead of the United States in math education and were worth copying. But the comment that it also included the practical methods of the English school was also a signal that we're not going to go too far in adopting the French methods. So the US and the US math education generally was influenced by the English and tended to be more rule-based, more based on memorization. And so when they talk about the practical methods of the English, that's what they're referring to. The ad also says that the books were used at West Point, so that was also part of the appeal. So here's another ad. This is an ad from 1868, so more than 30 years later. It refers to Davies' complete course of mathematics. So the idea was that if you worked for a school district and bought this course of books, that would be appealing. It was a single decision. You wouldn't have to make choices about individual books, and you could stay within the series from, your first arithmetic book through calculus and beyond. This ad also makes the claim that 2/3 of Americans receive their mathematical education from Davies' series. So this is an excerpt from Davies' obituary in 1876. So this is more than 40 years after the book was originally published. The claim is that nearly every collegiate or high school boy who's graduated since 1840 remembers the hours he expended over Davies' Bourdon. It also claims that these were at one time in every institution of learning in the land. So it is an obituary, but these claims may be true. We do know that the publisher sold more than 7 million copies of Davies' books. So even if these claims are exaggerated, it's clear that these books were incredibly influential for more than 40 years. And it's not an exaggeration to say that this book formed a de facto algebra curriculum for the United States for a good chunk of the 19th century. So this was my question when I read about the French influence in the United States and the dominance of Davies' book in particular. I'm sorry?
Just wondering, are you going to talk about why he was in Fishkill? Why he died? Or do you know anything about that?
About his passing?
Yeah, it says Davies died on September 18th at Fishkill on the Hudson.
I don't know, say more about that? Why is that? And I hadn't noticed that. Why is that an interesting fact?
Because that's right next to Beacon where I grew up.
Oh.
So it's interesting to me.
Oh, okay. I'm sorry I didn't address that or anticipate it. Okay. So my question was, if we have this translation of a respected French algebra textbook that was so influential in the United States, why did the United States continue to lag so far behind? So there are many political and social reasons for this. I don't want to claim that it was solely because of one textbook, but I do believe that that this textbook was a problem. And I'm going to obviously talk in more detail about what the problem was with this book, but my claim is that it may well have set back US math education simply because of its influence. So let's take a step back and look at the French origins of the book. So Davies was a graduate of West Point, as I mentioned, and a professor there, and this particular book was adapted for use at West Point. Davies' adaptation of Bourdon was part of a much larger effort of the superintendent of West Point, Sylvanus Thayer, to orient the school toward the model of the Ecole Polytechnique in Paris. And a lot has been written about this. I won't go into too much detail, but basically Thayer traveled to Europe to tour their educational institutions on behalf of the US government. While he was in Paris, he purchased a number of books on mathematics and on military engineering that became part of West Point's library, which is this. This is actually a photograph from the museum at West Point. They actually have some of his books on display, but there were 1,000 books, right? This is just a small sampling. Thayer also recruited a graduate of the Ecole Polytechnique, Claude Crozet, who became a professor of engineering and taught descriptive geometry at the school. Additionally, he instituted a testing and ranking system to mimic the way they had things structured at the Ecole Polytechnique. So similarly, every graduate would emerge from the school with a number, a rank, that was based on their academic performance as well as some discipline measures. And so the top graduates would be offered a post in the Corps of Engineers. So when he was superintendent of West Point, Thayer also implemented French language classes so the cadets could read the French textbooks in their original language. This is from the year 1821. This is from Thomas Prévoraud's dissertation. He's written quite a bit about the French influence on the United States. So at West Point, fourth class actually means freshmen, and first class means seniors. So it shows you basically what their schedules were. The freshmen would study a lot of abstract mathematics, and then it became more practical as they moved up. But you can see, like, there's a lot of just French language classes that are built into the day. Thayer also encouraged the translation of French textbooks, which is how this particular translation happened. But one thing to understand is that West Point was not the Ecole Polytechnique and really couldn't have been modeled that closely after it. The Ecole Polytechnique was part of an established centralized education system, and West Point, by contrast, was founded in 1802, so it was a new geographically dispersed country that was decentralized in terms of the government. We have a very strong federal government today, but when the country was new, of course, the government was very weak, and it wasn't even clear in the very beginning that the federal government had the power to start a school like this. So West Point was already starting off like in a completely different situation than the Ecole Polytechnique. But in addition to this, there was no exam to enter the school, and that really changed the nature of the school. In fact, throughout the 19th century, there was no entrance exam. So the Ecole Polytechnique, by contrast, from the time it was founded, had a pretty rigorous entrance exam, which included mathematics, science, language classes in French and German, and also mechanical drawing. So this was actually part of the philosophy of West Point. It wasn't an accident that there was no entrance exam. It was sort of an equitable idea that we would take cadets from all over the country, from all social standings, and once they were at West Point, we could turn them into engineers. That was the idea. But because of this crucial difference, cadets coming into West Point really did not have the capacity to study mathematics at a high level. And in fact, one early graduate referred to it as the elementary school at West Point. So while Thayer was important, he could really only go so far in transforming West Point. Another thing to understand about West Point is that Charles Davies graduated under the old system, before it had this curriculum, before it had the testing and ranking system. Davies himself had very little formal education. He didn't speak French. He didn't even study it. He only spent 2 years at the school because there was no formal curriculum. They would graduate people whenever it was necessary to have more soldiers. And he began teaching at 19 years old. So how could someone with so little formal education write and translate these complex texts? You might think that he was a self-taught genius. He wasn't. He was a man of ordinary intelligence, according to the people who knew him. Is everything okay? All right. So these are quotes from a man who eulogized Davies. This was a colleague of his at West Point. He was Davies' predecessor and also his father-in-law. So he wrote an entire essay about Davies, and he had many wonderful things to say about him. But even Professor Mansfield said that Davies was brought up in the backwoods on the frontier. He had very little education or acquaintance with the outside world. He found little difficulty in mastering the simple curriculum of studies at West Point. And here he says, the books and writings of Professor Davies are not those of a brilliant genius. So that's what we're working with here. All All right, so this is the book that was adapted for West Point. I mentioned that part of Thayer's reform project was to translate French mathematics texts, and Bourdon's algebra textbook was one of the books. So now we come to the part of the talk where I describe what mathematics was actually transmitted to the United States. Bourdon's algebra book was fully modern at the time it was written. Bourdon himself was a graduate of the Ecole Polytechnique. He was affiliated with the school for 20 years as an admissions examiner. He aligned his book explicitly with the entrance exam of the school. In fact, if you look at the table of contents, there are little stars next to the parts of the curriculum that appear on the exam. So this was really the state of the art at the time it was written in terms of algebra textbooks. However, there was a shift taking place in mathematics at the time, and Bourdon's algebra textbook really reflects this shift in thinking. It really, I'm going to talk in more detail about it, but it really reflects a curriculum that's in transition. And so while it wasn't outdated at the moment it was written, it soon would be outdated. Just to orient you, it was only 4 years before Cauchy wrote his famous textbook on analysis that it served, not that everything changed in that moment, but it served as sort of a marker, a milepost about where mathematics started to become really more rigorous. And Bourdon's algebra textbook really reflected an older way of thinking. So Bourdon's book reads as sort of conversational and informal. It relies on intuition more than proof. It's also logically inconsistent in parts because he doesn't use domain restrictions to prevent division by zero. And he points out some of these contradictions. It's not that he's unaware of them, but it doesn't bother him because his view, and my understanding is this was characteristic of the view of algebra in this earlier time, that algebra was involved a little bit of hocus pocus, and it doesn't always give you an answer that it makes sense, but it's so practical we use it anyway. That was sort of the idea, as opposed to, and Bourdon says this explicitly. This is not my characterization of Bourdon. He says that geometry and arithmetic involve things of the real world, because the idea was that you could connect it to things that you could see and touch, whereas algebra was, in his mind, more of a manipulation of symbols. All right. So I have to add one more complication here. As I mentioned, Davies didn't speak French and was frankly not that highly educated before he started teaching at West Point. So how did he write an entire series of mathematical texts? The short answer is that he didn't. He mostly plagiarized them. And so this was the intermediate step of this adaptation. Bourdon wrote his book in 1817. Edward Ross, who was a student and then an assistant professor of math at West Point, translated Bourdon in 1831. And so Davies' adaptation is actually based on Ross, not on the original Bourdon. But it's interesting because Ross's book is a very line-by-line translation, and I'm not making a claim about whether it's a good translation or a bad translation, but it was definitely an attempt to be true to the original book. So if there was something that he took out, he made that explicit. And in fact, he did take some, we're going to talk about that, he did take some things out of the original book. But at the time this was written, it was the most complete translation of Davies that existed. So it was an important book. Right, so Edward Ross's translation eliminated certain advanced topics, but otherwise it really was a line-by-line translation. I guess I also wanted to mention that Ross's time at West Point as a student and then a teacher coincided almost exactly with Thayer's superintendency. So he received these French language classes, and it makes sense that he was heavily influenced by Thayer's vision of what the school was supposed to look like in terms of the French mathematics. So this slide, I don't expect you to read the details of it, but it shows sort of visually the chapters that Ross kept from Bourdon, right? The ones that are in green are the ones that were omitted. So they tended to be some of the more advanced chapters, such as the theory of equations, theory of sequences and series. And Davies eliminated exactly the same chapters. You can see the chapter titles look a little bit different. You might think just by looking at this chart that Davies is basically just a translation of Bourdon, but with some of the chapters removed. It's a little misleading to look at it this way because Davies made extensive changes even to the chapters that he kept. And so this is what I want to focus on now. I have a couple of slides that help us visualize those changes. So this is a comparison of the books by page number, and I divided them up into basically easy, medium, and hard material. So the blue represents page numbers that are dedicated to basic algebra, such as operations with monomials and first-degree equations. The orange is second-degree polynomial equations and higher. And then the gray is more advanced material, such as exponential equations and series and so forth. So you can see that Bourdon's book was massive. It was almost 700 pages, and a lot of it was this more advanced material. So Ross, you can see, took out a lot of the advanced material and some of the stuff on polynomials. It's hard to see exactly from this diagram how different Davies was from Ross, so let me show you one more way to think about it. So this is basically the same material, the same data, comparing the three books, but this time by what percent of the book is dedicated to each kind of material. So here you can see a little bit more the changes that Davies made to Ross. He eliminated some of the more advanced material and actually added in some easier material. All right, so to recap, Bourdon's book reflected a curriculum in transition. It represented a particular way of thinking about math that would soon be outdated. Davies changed the book in several specific ways. His changes in content, he eliminated whole sections of advanced material. He added in more elementary material, which was also plagiarized. He eliminated some of the more advanced or progressive ideas, even within the chapters that he kept. And I'm going to give you some examples of that in just a minute. He also made changes to the pedagogy of the book, consistent with his philosophy. He was coming from this sort of English-American school of pedagogy where things needed to be made explicit. He wrote out the rules in numbered lists, sort of, do this, then do this, then do this. He removed the reasoning and the context in some places, and I'm going to show you an example of that. And he also included more routine exercises. So in short, it was a very different book than the one he had started with. So here's one example I want to discuss of how Davies removes reasoning and context from Bourdon. So in Bourdon's introduction, I told you his book comes across as very conversational. It's almost like he's speaking to the reader and explaining to them or convincing them of the importance of algebra, trying to explain to them what it is and why it's important. And so he makes this case for algebra as a generalization of arithmetic, by using this example. So this is a little theorem that's not that interesting by itself. But basically he says if you have A less than B, and he assumes that M is positive. He doesn't actually say that. And then you add the same number M to the numerator and denominator, you end up with a larger fraction. So again, not a super interesting result, but he starts, I know you can't see the details of this, but he actually starts with a numerical example, which is 5/12. And then he shows how if you add 3 to the numerator and denominator, you end up with a larger fraction. And then he assigns variables and proves it generally. And you can see, like, this is quite, a long discussion where he's talking about this theorem and convincing the reader of the power of algebra to generalize results. So when Davies adapted this, this is very characteristic of Bourdon, right? To start with the concrete example and then to generalize. And this is very characteristic of Davies. He takes this little theorem out of the introduction. In fact, he doesn't include Bourdon's introduction. He includes it later in a chapter on equations of the first degree. And all he says about it is this: we will add but a single proposition more on the subject of fractions. It is this. So he takes out the whole discussion, the context. The reader's led to believe that this is just a fact that they're supposed to know about fractions. All right, let's look at the treatment of negative numbers in the book. So I mentioned that Bourdon's book reflected a curriculum in transition. So his treatment of negative numbers is a good example of this. He has this very restrictive view of the idea of number, that number represents tangible quantities. So he distinguishes, like I mentioned, between arithmetic and algebra by saying that algebra deals with imaginary things, right? So he's talking about negative numbers. And he assumes in the beginning of the book that all of his quantities that he's dealing with are positive, and he doesn't introduce negative numbers until much later in the book under his theory of negative numbers. And when he does discuss it, he actually says that negative numbers, the context is he's talking about algebraic results that happen to be negative. So if you have 6 minus 13, and you end up with a negative result, he says, well, this is an embarrassment, but it's okay, we can explain it. And he says to think of a number like -7 as subtracting a positive. So it's as though he doesn't quite give negative numbers the full status as numbers. He reinterprets them as an operation with a positive number. Later, Bourdon gives a more modern or progressive interpretation of negative numbers as numbers that are less than 0, and that's what this is. He says, here's this other way you can think of negative numbers. He starts off with this pattern, 6 minus 1, 6 minus 2, et cetera, going all the way to 6 minus 9, and then he shows the pattern, right, and says, so here's this way of thinking about negative numbers, that they actually are numbers and they're less than 0. So this is, again, typical of Bourdon. He has these sort of old-fashioned views of mathematics, but he's clearly aware of the more modern views, and he incorporates them, at least to some extent. Davies, on the other hand, he removes this more modern discussion of negatives altogether. He just takes it out. And he leaves in the earlier statement about negative numbers being imaginary beings. Here's one more example of this, where Davies takes out some of the more progressive ideas, some of the more modern ideas, is in the use of functions. So this, again, I don't expect you to be able to read this because it's in French and it's tiny. But this is basically the page where Bourdon introduces functions. And what's interesting about it, I think, is that it's in the middle of a chapter on quadratic equations. There's no, it's not treated as a foundational topic. There's no big headline saying functions are coming up now, this is what a function is. He just sort of throws it in there. And that is true of his treatment of functions generally. He treats them not as a foundational topic, but something that's sort of ancillary, and he makes use of them when he finds it useful to do so. So here he's talking about maxima and minima, and he finds it useful to think of it in terms of functions. So, let's see. He uses the word function more than 200 times in the book, but again, it's often as an aside. And in general, his algebra is not one of continuously varying numbers. It's more of, it comes across as the algebra of static unknowns instead. So Davies actually, this chart shows how many times the word function was mentioned in each of these editions. You can see in Bourdon's 1828 edition, I'm looking at that one only because it was the most recent edition before Ross came up with his translation. So it wasn't that different than the 1817 book, but it doesn't matter, but that's the one I'm using. So he used the word function 227 times. Ross used it only 87 times. So I mentioned that Ross's book was a line-by-line translation. The fact that he used the term function so much less really reflects the fact that he's just taking out a lot of the more advanced material. He's not changing what was there. Davies, on the other hand, you can see in his 1835 book, he used the term function only 22 times. So wherever he was able to get rid of the term, he just took it out. And in these subsequent editions of his book, you can see he added like a little chapter, which is why it bumped up at some point. But by the time of his last edition in 1877, the word was only used 10 times. It was more of like a vestigial feature at that point. It wasn't really an important part of the book. Meanwhile, in France at this time, it's not clear, from what I've read, it's not clear exactly when French schools really started to use the concept of functions extensively. They were used first in the context of algebra and then sort of worked their way down in the curriculum. And you can tell that by looking at the curriculum for the different entrance exams for the Ecole Polytechnique. But it is clear that in France they were at least moving in that direction. Meanwhile, in the United States, to the extent this reflected the curriculum of the United States, was moving actually in the opposite direction. Whoops, that was it. All right, so let me wrap up now. There's been much written about the French influence on American mathematics in the 19th century. I think a lot of researchers have been appropriately skeptical about the extent of it, but many haven't. Some said that the textbook translations were the major way that French ideas were transmitted to the US, and that may be true, but I do believe that it's appropriate to have some skepticism when we look at translations, and it's appropriate not to assume that just because a translation of a book came over to the United States that it was the equivalent of the original book, because that certainly wasn't true here. So I'll stop there and take questions.
Thank you.
Thank you.
We have time for questions.
Is Davies' book available on Google Books?
It is, yeah. Many versions are available.
How did you get interested in this?
So, gosh, my first research project in the history of math was a project about puzzles. I was interested, I did a lot of math puzzles in my own practice, with my students, and I was interested in the history of puzzles. And once I started to look at old sources, I came up with a lot of stuff that interested me, but one of the things that interested me is the influence of European mathematics on America, because I was able to trace a lot of old puzzles from European sources to the United States. And so that kind of opened this other can of worms to look at the French influence more generally.
Anybody on Zoom have any questions? Just going to see.
So,
Go ahead.
to what do you ascribe the great popularity of Davies' books? Do they have some magic it?
You know, one thing I ask myself about why these books took off is whether this really could have happened anywhere else, or whether this was sort of an American phenomenon. And I think, you know, America was a new country. I don't think we really knew who our experts were. We didn't have institutions yet, or at least not many. But the one institution, excuse me, that we had in terms of math and science was West Point. And so when people saw that Charles Davies taught at West Point, that was sort of enough. And then it also is true, though, that the publisher engaged in some really aggressive tactics, including like the idea of bundling these books together, stealing other people's work. Like the publisher was actually sued at one point. It's an interesting little case that made it all the way to the Supreme Court. And Davies and the publisher were basically claiming that their adaptation of somebody else's book was different simply because they added a couple of diagrams to it. But otherwise, it was just lifted completely from somebody else's work. And so, like, that was pretty aggressive, right? So, like, to create this complete course of mathematics by taking other people's books, by marketing as, you know, this comes from West Point, therefore you can trust it. I think that's why it became popular.
Makes good sense.
Right.
Other questions? Well, seeing none, let's thank Sean again, please.
Thank you very much.